Alright, now we're going to do some word problems. If you look at the top here, you'll see that I gave you all these lovely gifts, all the equations. On a quiz, you would have to know these equations yourself, but they're very familiar because you've used these before. The only thing different is that now you're going to have the unknown variable up in the exponent. So you'll have to use logarithms to solve these. All right, let's take a look at the first one here. The population of the North Pole is currently 800,000. So that's what it's starting at, is 800,000. So our starting amount is 800,000. The population grows at a rate of 1.5% per year to the nearest year. So that's important. How long? That means I don't know what t is. How long will it take for the population to be 1 million? All right, so we're talking about growth. So that means we're going to use the formula within this present, our growth formula. Our starting amount is 800,000, so that's A. Our ending amount is 1 million, that's Y. Our rate is 1.5%, or 0.015. We're changing it to a decimal. All right, we plug this in. Y is 1 million, and that equals A, which is 800,000, times R, or 1 plus our rate, 0.015, to the t power. All right, we're going to try to simplify this a little bit. In the parentheses, I've got 1 plus 1.05, or 0.015, to get 1.015 to the t. I cannot multiply this 800,000, but I can divide by it to get rid of it. So 1 million divided by 800,000 is going to give me 1.25. So I've got 1.25 is equal to 1.015 to the t power. There is no way that I'm going to be able to balance these bases. So I'm going to change it to log form. Or you could log both sides. If you did that, the base would have to be whatever the base over here, which is 1.015 is. But again, I like my shortcut of changing it to log form. So I've got log. Remember, the base is whatever has an exponent, so it's 1.015 to the 1.25, and this is going to equal t. Now, I'm essentially done. I just need to change this into a format that I can plug into the calculator. My common logs, which looks like this, when I plug that into the calculator, that's going to tell me that I've got 14.9875, something like that. But the problem said to the nearest year. So if I round that to the nearest year, that's going to say, or give me 15 years. So it's going to take 15 years for the population in the North Pole to reach 1 million. All right, let's try another one. Next one is about Santa. He wants to buy a very nice, very special, very expensive gift for Miss Claus next year. So he is going to be smart, and he's going to invest $1,000 into a Christmas bank account that has a 4% interest, compounded quarterly. As soon as you see that compounded, you're going to use one of your compounding formulas. So since it said quarterly, we're going to use this formula. The other one would be if it was compounded continuously, the one with the E. All right, so he wants to end up with $5,000. So A is our ending amount, P is our principal, our starting amount. The rate is 4%, so 0.04. It's compounded quarterly, so quarterly means 4 times a year, so N is 4. All right, so I'm going to plug all these into the formula. So I've got 5,000 is equal to 1,000 times 1 plus 0.04, my rate, divided by the number of times I'm going to compound it, times 4 to the t. Again, you see t up in the exponent, which means we're going to have to do logs, because the inverse of an exponent is logs. I'm going to divide both sides by 1,000, because I'm not going to be able to multiply that through. So I have 5 is equal to, everything in the parentheses there is going to end up giving me 1.01 to the 4t power. Now is where we need to change that exponential form into a logarithmic form. So I've got log, the base is whatever had the exponent, 1.01, of 5 is equal to 4t. Use your common logs to rewrite that as log 5 over log 1.01. Now they have a base of 10. You can use your calculator. When you do that, you should get 161.747, a bunch of other decimal places, is equal to 4t. So divide that number by 4 in your calculator, and you should get 40.436. Divide that by 4. T is equal to 40.463. I'm going to round one decimal place because it said to the nearest tenth. So it's 40.4 years. That's a long time, Santa. Alright, let's try another one. Alright, this time the elves are going to be investing some money. So they want to invest $5,000 into a CD that pays 6.75% annual interest compounded continuously. As soon as you see that word continuously, you need to use the formula in the present that has an E to it. So A is our ending amount, P is our starting amount. To the nearest tenth, how long? As soon as you see how long, you know that you don't know what T is, and that's going to kind of give it away that you'll have to use logarithms. They want their money to double. So we're saying that we're starting with an amount of 5,000. Double that, 5,000 times 2 would be 10,000. Alright, look to see what happens here. When I plug these numbers in, I have 10,000 is equal to 5,000. E, my rate was 6.75%, which as a decimal is 0.0675, so 0.0675 to the t power. I'm trying to get t by itself, so I'm going to have to divide both sides by 5,000. Notice when you do that, 10,000 divided by 5,000 brings us right back to that 2 when we were talking about doubling. So you can essentially just skip the 10,000, 5,000, and just write 2 is equal to e to the 0.0675 t. Sometimes they won't even give you a starting amount, and you'll just have to start with the 2 for the double. Alright, again, we're stuck here, so I need to change this to log form. When you see e, you need to think natural log. Alright, so I've got the natural log, base e, I don't even really have to write that base e there, that's why I need to use natural log, of 2 is equal to the exponent, 0.0675 t. To get t by itself, I'm going to divide both sides and use your calculator. All you have to do is type ln2 divided by 0.0675. Be careful with your parentheses. If you did it correctly in your calculator, you should have 10.2688. Rounded to the nearest tenth, it said it right here, nearest tenth, would be 10.3 years. Alright, so it'd take them a little over 10 years to double their money. Alright, so the next problem says now they want to know how long it would take for them to triple their money. So exact same type of problem, but this time I want to triple it. So I'm still compounding continuously. In all honesty, I don't even care how much they're starting with. I want A to just equal 3. If A is 3, that's triple. P is just going to be 1. So you can skip that 5,000, 15,000 if you'd like. So 3 is equal to e to the rate, let's see, what was the rate from before? It was 0.0675. 0.0675 to the t. Now, if you're really curious where I'm getting that 3 from, you could have tripled the 5,000. So that would have been my original problem, and then divide by 5,000 to get to this step. I just don't want to do extra work if I can help it. Alright, now I'm going to change this to a natural log. Natural log base e, I don't have to write that, of 3 is equal to 0.0675 t. Divide both sides by 0.0675. Use your calculator to see how many years it's going to take to triple the money. Yeah, the calculator says 16.2757, so that would be rounded to 16.3 years. Alright, make sure you guys are trying that on the calculator, because when you do type it in, it's ln open parenthesis 3. You have to make sure that you close that parenthesis before you divide. Alright, now make notes on your paper of where you are confused, what you need help with, and I will go over any of those questions with you when I see you next. Bye-bye.